Okay, well, hello everyone. This is Paul Mink, and this is my final presentation, the presentation for the final project in 605-782 for fall 2015. And the project that I did is a tool which is used for managing salt domes. So essentially, the Salt Dome Manager is a tool for managing salt dome data. And of course, salt domes are used in Maryland, where I live, and in many other places to store road salt. And that road salt is used to treat roadways, generally during snow or ice events. And it's actually the primary method for removing ice from roadways during, after, and sometimes even before winter snowstorms hit. Um, road salt itself is it's good in terms of providing good, safe travel conditions. If the temperatures don't get too cold, it's a very effective means of removing ice, and it's fairly inexpensive compared to some other alternatives like a more commercial liquid de-icer. The bad part is that road salt can also be harmful to the environment. When you put road salt down, it stays there for a while until the snow melts, and it eventually gets into water and the ground and other places, and can be very bad for the environment in some cases. Another bad thing is that supplies can be quickly depleted during very severe winter snowstorms, and of course, if your road salt supplies are being depleted and you can't treat the roads, and you need to get more supplies into the dome, that can be very difficult too. You can't resupply yourself under certain circumstances. So when we're dealing with salt domes and road salt itself, it can be useful to measure how efficient we are at using the road salt that we have. And really that means that we'd like to keep the costs down. It's not cheap, even if it's maybe the least expensive alternative. And we also want to minimize the impact to the environment by using only the salt that we really need to use on the roadways. So what kind of questions might we ask if we're trying to have efficient use of our salt? Well, we might want to know how much salt do we have. We might want to know how much salt is used when it's snowing, where that salt gets used. What is your rate of usage? How many lane miles of highway or roadway do we need to treat for each of these salt dome structures? So the Salt Dome Manager application gathers data related to salt usage in two different ways. It gathers data related to the physical dome, and these are the kinds of things that are not an operational thing during a major snowstorm. But the second thing is we actually do want to capture separately those things which relate to operational data during snow events. So salt dome data, the non-operational type of data, you might just want to know how much salt is in each of your salt domes. You might want to know how many lane miles are assigned to that dome that they need to take care of. What kind of roads are being treated? Are they major interstates, or are they small or secondary roads? And what is the location of the dome? And so when we collect this kind of data, it's really just the attributes of the dome. So we really want to just say, hey, we have a dome, and we have some basic questions, about salt or how much capacity it has, and that kind of thing. Whereas with an event, we really want to understand the operational details during a snowstorm. So during a storm, you want to know how much salt is being used. You want to know how much snow you're treating. So, if you got so many inches of accumulated snow, you want to know that. You want to know the rate that your salt supplies are being depleted. That can help you determine if you've got enough for a longer term event. And you'd like to know where that salt is actually being used. And for this type of event reporting, we really have each event being completely separate with a series of child reports beneath it. And each of these child reports contains information such as how much did it snow and how much salt did we put out, to take care of that, and what time was that, and what was its location, and that sort of thing. And each of these events is really self-contained. The event itself is just a parent object, if you will, and each of the reports is a child to that parent object. So the application itself, and we'll get into a demo of how this stuff works in a moment. The application itself is, the design approach is a standard model view controller, where we have a controller servlet, which is talking to a model and communicating with a database and giving information out through JSPs and HTMLs and served up through web browser. In this particular application, the database is a MySQL database. And I'm using the Java Persistence API. And so it's a little different way of accessing a database than doing standard SQL queries. This actually kind of provides an object mapping between your Java objects and the database tables. It's an object-oriented data persistence mechanism, and it's a really neat abstraction layer between the application and the database. I think there's a lot of benefits to that. It can be a little tricky to work with at times, but this is how the database access is being performed in the Salt Dome Manager application. The user interface primarily uses the Bootstrap CSS library, and on top of that, I'm using several third-party libraries, and I think most folks here are probably using jQuery in their application. I've got one or more, at least two maps where I'm showing data on a map, and that's being served up with the Leaflet.js JavaScript mapping library. I'm using another JavaScript library called Data Tables, which is helping to provide a almost CRUD-like viewable data format. And JHU plot is being used for charting and graphing and those kinds of things. And these Leaflet, Data Tables, and JHU plot are actually interesting because they work exclusively in this case through AJAX to provide data to the user. And essentially what happens is you have whatever the component is, whether it's a map or a data table or whatever it is, making an AJAX call back to a controller, which is a servlet. The servlet is then doing a database query and getting a result set back, and then it's translating this data into either JSON or GeoJSON in the case of the map, and then it provides it to the JavaScript library. And then the JavaScript library knows how to show that to you for whatever the application is. So there's actually quite a bit of AJAX going on in this application. And just to give you an idea, this is a little piece of code from the app. And this is where we're loading the map, and we're going to show the counties for the state of Maryland, where I live. And then we're also going to put some Salt Dome data on top of that. And in both cases, we have GeoJSON AJAX calls coming directly back to the application. The first case with the JSON data, this is actually the Salt Dome data. And so it's making a call back to a servlet. The servlet's providing the data. It goes to the database, gets the data, and then it massages it into a GeoJSON format and then provides that back here. And of course, this Maryland Counties is a little bit different. It's doing a direct call to a file, which is a GeoJSON file. So there's no servlet involved. It's just basically reading this GeoJSON formatted text file because in this case the shapes of the counties don't really change. They're static for the most part, so we just treat them as static. And so there's a lot of this kind of stuff going on in the application. It's not really visible to the user, but it is providing a good user experience. So let me go ahead and begin with an application demo. So this is our application, Salt Dome Manager, and when you first arrive at the application, you will be greeted by the map, which has that. This is where the source code came from that we just looked at. But so when we load this page, the AJAX call happens. The shapes of the counties is drawn on the map, and then these little sort of push pins or markers are providing us with the locations of all of the salt domes. And for each of these, if you click on it, you'll get a little pop-up that shows you, the name of the dome. This is a friendly name. We can change that. Then we see the county that it serves, the percentage full of salt, how full is it, and how many interstate miles, primary road miles, and secondary road, these are road types, how many miles it serves or are assigned to that salt dome. And we have, for each of these, we can basically look at the data and get a sense of what's going on there. We also have on the front page below that, this is an example of the data tables JavaScript library. And the data tables library is it's actually really neat if you've not looked at it. It's free and open source and a great way to present data. It does the same thing. It makes the AJAX call. It gets the data back, and then there's some formatting that goes on that allows us to display it. But you can see here it's a really nice browsable grid of some of the data. It's also very searchable, so if I wanted to start searching for something, it's really good at doing that too. So, and then you can tell it's very responsive and very fast. And this is what anybody who's not logged in would be able to view. Now, if you want to actually start doing things like managing the data with the domes or creating an event, that sort of thing, you would come to the Manager's menu item, and let's say we want to list the salt domes that we have in the system. And as soon as we do that, the application is going to prompt us for a login. So this is a case where you need the Manager login. And when you log in, don't really need that. We pull from the session the username, and we just kind of say, welcome manager. So that's your name, and we'll display that at the top part of the menu. This is our list of salt domes. I think there are about 23 in the system. And this is another of the data tables grids, and it's searchable as well. It's sortable in pretty much every column. And if you want to look at the details, let's say we've got this particular dome is called My Dome. It's its friendly name. So we look at the details of My Dome. We show where it's located by lat long. We put a little red dot, and we kind of go ahead and show you the pop-up for that, the info window. And then we've got these dome details, things such as the name of the dome, how much salt is currently in the dome, what its maximum capacity is, what its geolocation is, the county it serves, and the lane miles of different types that are assigned to it. So that's the details of a dome. If we return to the dome list, we are able to edit some of the dome data. So for example, we could change the dome name if we wanted to. So say My Salt Dome. We could change the amount of salt that's in there. So if you were to get a delivery of salt, you'd be able to say, oh, we have more now than we used to. And then with capacity, we actually allow you to edit this value, because sometimes the salt domes actually fill up, and they'll sort of create piles of salt next to the dome. And so the capacity, it's kind of weird, but we want an accurate measure of what's being used. So we will allow them to change the capacity. And of course, with the different road lane miles, construction, new projects, housing, those sort of things going on, these values can change over time. There's some non-editable data, so we don't change the county that the dome is assigned to. The domes are physically located in the counties they serve, so that wouldn't be a very practical thing to be able to do. Percent full is a calculated value, so we don't change that. We just calculate it each time. And because in this application we don't relocate domes, there's no need to change the latitude or the longitude of the data. So we can save that. And so there's My Salt Dome, and here's the information that we have for that. So it's fairly straightforward. You can view the details, and you can change some of the details, and make updates, and keep the salt quantities current, and keep the percentage of salt current as well, since the capacity is somewhat not exactly static. And that was an example of what we were talking about earlier when we said that if we look here again in the presentation, we were just kind of looking at Dome 1, Dome 2, Dome 3, and it's got these values assigned to it. Let's take a look now at snow events and how they work. So as I said before, you've got these sort of parent items, these events, and then the reports fall in under it. So if we look at the events that we have in the system, here's an example. Let's go back here. Kind of show you how I got here. So this is an example of events in the system, and each of these events has 0 or more reports assigned to them. So let's say this guy doesn't happen to have any 1051. It's a good test case. So you can see under this parent event, we have a series of event reports that are assigned only to this event. They're not assigned anywhere else. And that's an example of what we're looking at here with the different types of events. For each of these events, I will say that you'll notice that there's an end time, a start time and an end time, as well as the event IDs. And in this column, we have the value active for the end time, which means that it doesn't have an end time yet. It's sort of in progress, if you will. And one of the concepts of this application for tracking salt is that you can only have one active event at a time. It would be very, very difficult to have multiple active events and to try and guesstimate, whether the salt you were spreading was for event 1 or event 2. It's really one event if it's happening concurrently. So that was a design decision that I made. And as a matter of fact, if you were to attempt to create a new event, it would tell you that there is currently an event open. It gives you a little bit of information, such as its ID and when it was started, and gives you the option. You could close that event, or you can go right to it if you wanted to start doing some reporting. So this is the currently open event, which has no child reports currently. Let's say we wanted to submit a field report. So here's the salt dome I edited earlier, my salt dome. And let's see, they've got 1 inch of snow, and maybe they've used 10 tons of salt in treating that 1 inch of snow so far. So here we are with the my salt dome. We have 1 inch of snow accumulation and 10 inches of salt usage. I'm going to widen this just a tad so my button to show properly. And this is the sort of thing that would go on during a snowstorm. So you would have these different places that are coming into the system, and they're saying, well, let me submit some reports and let people know how I'm using salt and what my conditions are with snow and that sort of thing. So let's see. Just create a few more of these. This is kind of what, the sort of thing that would happen over, hours or days of time. So you've got these different salt dome locations, and they're creating their data inputs just constantly over time, and they're all time stamped, and you can see that. So this is sort of the process of how we would begin to collect this data from the field during an event and during operations. And as you go along, if you start to collect data, this is where we get to the point now where we can start thinking about metrics and try to get a sense, are we doing a good job, or how are things going? And the View Event Metrics button will produce from the data that you've input. So I just created some reports to that event. It was empty when I started, and I submitted reports for 4 different domes. So the Event Metrics dashboard tells me the number of domes that are participating in this event. And it also gives me the combined total inches of recorded snowfall, which is a value that always accumulates. So if you had Dome 1 is treating 1 inch of snow, and Dome 2 is treating 1 inch of snow, then you really have 2 inches of combined snow that you're treating. And we do that because if you look at the tons of salt that's being used in this event, that's the total salt being used. So we want to be able to compare the total salt versus the total inches of snow that it's treating. And that kind of helps us to deal with the problem of area, which is a completely separate subject. But and then, of course, we have another part of the metric just telling us how many days has this been going on. So you may have these events going on for long periods of time. In fact, you may have the events going on after the snowstorm passes, because you might have melting of snow during the daytime and then refreezing overnight where the salt trucks need to go out and treat the roads again. Even though it hasn't snowed, they're using salt to keep the roads from icing over from the runoff and the melting. Another metric that we've been able to produce is how much salt each dome is using, and so this is the values. 820 tons for Bel Air, and 25 for Leonardtown, and 10 for my salt dome, and 25 for Westminster. And so we could have, if we had all say 23, we'd have a bunch of these bars in the bar chart here showing us the salt usage by dome. Another thing we'd really like to get a sense of is, how much salt do we use compared to how much total snow accumulation we've had. So we were kind of looking at this earlier. This is the total snowfall and the total salt use. Well, that's sort of the big picture, but over time, what does that look like? And so here we have, back when we kind of started with the first report or so, we had somewhere around an inch of snow, and we used 10 tons of salt to deal with that. And we're still using salt, as the snow's coming down. And, over here eventually we get to, maybe 3 total inches and 35 tons of salt. And you can actually see a trend starting to develop. And this was just my dumb luck at putting in some data that was pretty easy to follow. But you can see that we can definitely get a trend on the slope of this line would give us the amount of snow versus the salt use, which is an interesting metric because over time, if we were to say, well, here's the 7 total combined inches that we have at the end, and there's the 80 that we get actually from here. If there were a weather forecast that were telling us we had a lot more snow coming, we would be able to look at the dome quantities and look at the slope of this graph and try to get a sense as to whether or not we have enough salt to treat the roads for the snow that's coming. So it can help you make operational decisions based upon these fairly simple metrics, actually. And finally, another graph that I think is interesting that we pulled out of the data was, remember we had for each of the domes, we had the number of lane miles that were in the dome. And these are lane miles of different types, like lane miles of interstate, lane miles of primary roads, lane miles of secondary, which are your little small back roads. Now, for simplicity's sake, the application assumes that when you treat an inch of snow, you treat it on all of your different road types. In reality, that may or may not be true, depending on where you live and some other metrics that are involved there. So if you really don't think you're going to have very much salt and you've got a ton of snow coming, you might start just treating your interstates to try and keep those open first. But those are operational decisions. But for purposes of our discussion, we're really just assuming a very uniform salt coverage on all the different road types. And this graph can show us the different types of roads and how much or how many tons of salt are being used to treat the different types of roads. Which can be an interesting metric depending on where you live, because now most of these locations you can see they're somewhat uniform, I guess somewhat predictable. Your interstates, not as many lane miles, primary, and then your secondaries are just tons of secondaries. That's not true for every location. So if we were to go and look again at the map on the front page, so here's the state of Maryland where I live. And if you take a look here on the eastern shore, they don't get a lot of snow there, by the way, but they do get some on occasion. And there are no interstates here at all. So if we were being accurate about the types of lane miles we had, we would actually have zeros for interstates, and it would all be primary and secondaries in this location. Whereas if you were to look at, say, Baltimore City, there's 695s in the interstate, there's I-97, there's I-95, there's 70, there's 83. There's just a ton of interstates and interstate type of facilities in this area. So you would see, maybe a much larger number for Baltimore County for interstates than you would for, say, the eastern shore of Maryland. So it's an interesting thing to look at. So look at our active event again, looking at the metrics. So these are the metrics that we gathered, and I think these metrics do a pretty good job. Remember some of the questions we asked. Do we have enough salt for the storm? Well, the slope of this graph can help us determine that, and how much salt's being used by each location. This bar chart can help us determine that, and these are the usage by road type. So you had a big storm coming, you might want to cut back on the secondaries and apply that salt to other types of roads. Of course, we have all of the abilities here. If we wanted to come in and edit any of these reports, we can certainly do that. If we maybe entered something we didn't mean to, we can delete a report if we really wanted to. And of course, that I just deleted the my salt dome portion. So if we come back in here, you'll notice that that's gone now from our graphs, so we're not really showing that data here anymore. So this is how we would go about doing the reporting that we were talking about in the presentation portion. Now, in addition to this, I mentioned that you don't really know if you had multiple events. You don't really know, if the salt from one truck is going to treat event A and another truck is going to treat for event B. You really just have one event at a time. And so if I were to go in here and attempt to create a new event now, and we noticed this before, it will tell me, hey, you can only have one event open at a time. So you can go here and you can report in this event if you like, or maybe this event's been around for a while and there's no snow been falling maybe for a few days and we just didn't close this event for whatever reason. There's a new event coming. I'd like to use that event. So what we do is we close the currently open event, and you can now go back to the list and see that the one we were just working on has, actually sort it this way, what we were just looking at has been closed and it has an end time assigned to it. So now if I go back and I say I want to create or close an event, then I can get the creation screen where I can enter an optional name like my new snowstorm 20, let's call it 16 just for kicks. Let me go back to our event, and here we are. My new snowstorm is now an active event, and there are no reports under it because we haven't started reporting for this particular event yet. So that's the application. The information that we entered would be reflected on, of course, the map as well as any of the data tables if we had changed any of that. We showed the ability to log in. We showed these are secured portions of the application that everybody can get to. We're using some session data here with the manager, and of course we could just log right out if we wanted to. In which case, if we attempted to list events, it would ask us to log in again, which is fine. Okay, well that's the application. Thank you very much for watching this presentation. I hope you enjoyed it.